I will have to say that this is one of my favorite chapters, to be honest. I don't know. There we go. So, I'll get the lights. But chapter 9 is about non-right angled triangles. So, to me, I always think of it, it's like non-right triangle trig. Because I mean, normally when we think of trig, we think of SOHCAHTOA, we think of all of our right triangles. Well, the truth is that we can use some of that stuff with triangles that are not right triangles. And so that's what this chapter is all about. So today we'll talk about area. I believe tomorrow we'll talk about the cosine rule, which you should have done before. My 2 previous classes said you guys have done this area stuff that we're doing today before as well. And then next week, Monday and Tuesday, we'll talk about the sine rule. We kind of split the sine rule up into 2 different sections because we have that ambiguous case. We'll get to that next week. And then the last section, it's only 4 sections in this chapter, but the last section is, there's really no notes. It's like, here are problems that combine everything we've done so far. So, kind of tune all the pieces, and then you'll have to sort of problem solve. And then today is all about area of triangles. So, did you guys get your stat box? And here's what we already know. Hopefully, I'm hoping you guys all know the formula for the area of a triangle. Okay, good deal. Oh my goodness, I thought this was a line because I used the computer like last hour, and it seems like it's not, so I might have to fix that. So that's all fine and dandy when we have a triangle where we know the height. And we've got 3 examples here. We've got a right triangle with the height. We've got an acute triangle with the height. We've got an obtuse triangle with the height, sort of outside the triangle, but still perpendicular to that base in all 3 cases. That's nice. But what if we don't have a picture that has that height on it? Well, there are some other triangles that we can take a look at, and we're going to have like 2 different cases of, for the most part, types of triangles we'll work with. So today we will be focusing on just one rather than both. So, here are the 2 sort of cases that we have that we're going to talk about this sort of chapter. One of them is having 2 sides and knowing the included angle between them. Back in the day when you did congruent triangles, you would call it side angle side. So if I know 2 sides and the angle in between them. Another case that we'll get more into working with like tomorrow and next week is if I know all 3 sides. So those are just examples of when we know the angle in between and when we know all 3 sides. So again, it's not super important right now that we know the numbers. These are just kind of examples of both cases. If we have side angle side, we can use this formula. So this triangle is pretty important. I'm hoping you remember using triangles like this last year when you did this stuff in trig. So we usually use these capital or uppercase letters for our angles and then the lowercase letters for the sides. And so if I have angle A, side A is across from it, angle C, side C is across, and angle B, side B is across. You guys remember doing that kind of stuff? Like setting up the triangles with the lower and the uppercase? So the formula then is 1/2 A times B times the sine of angle C. So A and B, and then the angle has to be between them. So the angle must be in between the sides. That's like the really important part for this formula. Now, they wrote the formula in two other ways using the other angles, but really we just need to remember that one. At the very end in your stat box, I'm going to have you guys draw a triangle and kind of rewrite it yourself just to practice that. It is in your formula packet, listed just the way the first one is, the 1/2 A times B times sine of C. There's no diagram though, so you will have to remember that that angle C has to be in between those two sides. Now, were my other classes right? Have you used that with this one before? Some people kind of remember doing it? Okay. Alright, are we good? Are you talking to me? Okay. So we're going to find the area of this triangle. So, yep. So find the area of the following triangle. We can see that we have sides of 8 kilometers and 7 kilometers, and then that angle in between is 30 degrees. So again, it's really important that we have that angle that's in between. That's 30 degrees. Well, it doesn't have to be 30. In this case, it's 30. So I feel like I have to quick realign this because it's driving me crazy. But if you haven't drawn the picture yet, the sides are 7 and 8, and the included angle is 30 degrees. Again, those two sides form that angle. So we can go ahead and use our formula. So then my sides are A and B, it doesn't really matter what's what, and then my angle is that C. And I can just plug these right into the formula. So my area equals 1/2 7 times 8 times the sine of 30 degrees. One thing that's really important, now it is okay for you to use your calculator here. I'm going to do it the long way just because I feel like doing it the long way today. But it's definitely okay to use your calculator here. Really, really important to keep in mind that for this problem, it's degrees. You'll have some problems that give you the angle in degrees. You'll have some problems that give you the angle in radians. So just be really aware of that. You might have to switch your calculator back and forth depending on that. So just be aware of it. Now, again, I already said you can use your calculator, but I remember sine of 30 is on our unit circle, right? You don't have to, but if I look at my unit circle, I see that the sine of 30 is just 1/2. I'm just pushing myself to try and do this without a calculator. So then, what's half of 8? What's half of 4? So I end up with 2 times 7. You should get 14 square kilometers for your area. And again, you don't have to show all that work. Using your calculator is fine. And you'll have a lot of problems that aren't on the unit circle. This one just happens to be, so I used it because we just got off that chapter. But there will be a lot where you have to use your calculator. Yep, so every calculator is kind of different. And that one is probably under mode, and you have to have the right one highlighted. And then after it's highlighted, you just kind of have to clear out and go try the problem again. Okay, so the notes are really light on the examples. This is the only example we have in the notes right now. Just a couple other things I wanted to mention is you might have some problems where you're given the area and you're missing one of the sides. So you might have where you have a number for area, but then one of these is x and you have to solve for x. You might have problems like that. There are also some geometry problems with a rhombus or a parallelogram or a hexagon. And so if you don't remember those properties, you should ask me. I mean, we're going to do the stat box and then you're going to have a ton of time to work. So if you get to that rhombus problem and you're like, wait, I don't quite remember this, just ask, okay? And we can talk through it then. Also, you might have some word problems, and I always say when in doubt, sketch it out. So you don't have to try and imagine it in your head. You can sketch out that rhombus or whatever and go from there. So for the stat box, I want you to draw your own triangle. This is all listed here. You don't have to write this down. It's more important that you do it. So I want you to draw your own triangle, label the sides with lowercase letters and the opposite angles with the same letters but uppercase, but don't use ABC. I want you to pick your own letters so it's different from the ones that are in our notes. Maybe use your initials if you have a middle name. Some people don't have middle names. Yeah, some people have just different names. So then, once you do that, write the area formula. But you don't have to write the area formula 3 times like was in the notes. Just like pick one angle and write it. I just want you guys to get used to the way the lettering works, the lowercase and the uppercase and all of that. I like to write 3-letter words. A lot of times I use cat. Anyone have some good initials we can use? ATE. ATE? Alright. I was just trying to think about it in my head. So the angles get the capital letters, and then across gets the lowercase. So then just pick any of the angles. Let's just go with angle T. Doesn't really matter though. So I'd have 1/2 A times E times the sine of angle T. So that makes sense? Okay, again, I just really want you guys to feel good about the way this notation works. So then that's it. We're going to get to side stuff like after today. So that was just kind of a preview of like we're going to have side, but it should not be in today's homework. Good question. Alright, so this is 9A. I do believe you already have the calendar and assignment guide, or like assignment keep tracker.